This is the introduction to Apache Kafka on the Confluent Schema Registry. Now, once applications are busily producing messages into topics and consuming messages from them, two things are going to happen. First, new consumers of existing topics are going to emerge. There's going to be data in there. Maybe you put that data there. Other people are going to think, wow, that data is useful. I can do something cool with it. And those consumers are brand new applications. They could be written by the same team that wrote the original producer of those messages. Or maybe it's another team. Maybe people you don't even know, depending on how big your organization is. That's a perfectly normal thing for new consumers to do, to emerge, written by new people. And they're going to need to understand the format of the messages in the topic. That's the first thing that's going to happen. The second thing is, shocker, schemas are going to change. Maybe your original data model was absolutely perfect, but the world is a thing that undergoes development and mutation and change, and so our software has to change too. You need a way to keep track of those changes. Will my consumers down the line be okay when I produce messages of a different format? Do I have many producers upstream, some of which are the new version, some of which are the old version? Will my consumer be okay consuming different versions of those messages? Schema changes roll out in complex ways, and we need help with this. And the Confluent Schema Registry exists to solve these problems. So, Schema Registry is a standalone server process that runs on a machine external to the Kafka brokers. It's not a part of open source Apache Kafka. So it is this other component, a community license component made by Confluent, but it's widely adopted, highly standardized in the Kafka world. To the Kafka cluster, it looks like another application. I said in an earlier module that everything that's not a broker is either a producer or a consumer, and that's the case with the schema registry. It's Kafka just sees somebody producing and consuming to some special topic. But its job is to maintain effectively a database of all of the schemas that have been written into topics into the cluster for which it is responsible. And that database is, of course, persisted in an internal Kafka topic, and it should come as no surprise to you. It's cached in the schema registry for low latency access. So don't worry, there's not too much network round tripping happening here. The schema registry can be run in a redundant high availability configuration if you like, so you're not just dependent on one instance, it can be a little cluster there. Now, how does this work? What's the flow here? When I'm producing a message, I'm going to configure the producer with that properties map, that little list of key value pairs. I'm going to say, hey, there's a schema registry and it's here on the network. You give it a name or an address of where the schema registry is. When the producer produces a message, it's going to have an object that it's serializing, not just a string, but some compound object type in your language's type system that will have internally with it an ID. And it's going to tell the schema registry, hey, I've got this object. The producer now is connecting to the schema registry using the schema registry's REST API, saying, look, I've got this new object. I would like you to know about it. And the schema registry either says, I've never seen that one before. Thank you. Check. Got it. Or, yes, of course, I know that one. Please go on. Then the producer will take that schema ID, put that in the message, and produce it to the topic. On the consume side, the consumer also has this object, right? That looks like, if it's Java, it looks like a POJO, a plain old Java object. Nothing plain about it. There's a lot of machinery in there. But that object knows the schema ID, and the consumer will say, okay, this is the schema ID I'm using. Consume message from the topic. Is this compatible? Is this the same schema I'm expecting? And we'll go on to consume or not consume accordingly. Now, a part of the system here is that you get to configure your topic with a compatibility rule, whether it wants to be forward compatible, backward compatible, or both. Or I suppose neither is an option also, but that wouldn't be very interesting in terms of the schema registry. The basic idea is you want to know which order you plan to roll out upgrades in. So do you have more control over the produce side? When you've got a new version of a schema, do you know you're going to be able to roll out new versions of the producer first? And consumers might have to deal with versions in the future that they haven't seen before? They need to be forward compatible. Or do you know that on the consume side, you'll be able to roll out new versions of consumers when your schemas change? And there's lots of producers. You don't have control over all those. And so your consumers might have to be backward compatible. They might have to get old versions of messages of a previous schema version and deal with them in a functional way without throwing an exception. You've got that forward or backward or both compatibility there. And what this does is, in cooperation with the schema registry, it makes the producer throw an exception if it's going to produce a message that the consumers won't be able to handle. Or the consumer will throw an exception if it's about to consume a message that it thinks it won't be able to handle. Since you can't predict in the code what you might have to do with a truly unknown format, schema registry basically stops you, causes a failure in a predictable way of a produce or consume operation that would have broken something. That's the key idea. The Confluent Schema Registry supports these 3 serialization formats as of this recording: JSON schema, Avro, and protobuf. And depending on the format, if it's say Avro, you could have an IDL, an interface description language, available to you in the form of an AVSC file like you see here. And there's tooling, in the case of Java, a Gradle or a Maven plugin, that'll turn that AVSC file into the Java object, the Pojo looking thing that, again, all kinds of interesting machinery under the covers there. You should check it out. But that transformation is automatic. So now you have the object that represents that schema. There are a number of cool things about this, but one is that it drives collaboration around schema change to the IDL file, the AVSC file, so that you and your team, when you want to negotiate change, here's a text file you can use to negotiate that change. It can happen through a pull request. It can happen through conversation, but this is the source of truth. The build process can generate the Pojo, and the schema registry compatibility rules can do the work for you of making sure either your producers or your consumers check themselves before they do something that will cause an exception of an unpredictable kind. There are also compile time checks where if you can access the schema registry, you could say, hey, this topic, this new version of the schema, whatever the compatibility rules are, is this one going to be okay? So you don't have to deploy code and wait to see if it works. You can check at compile time, which is pretty darn cool. Now, I'd go so far as making this slightly opinionated statement that in any non-trivial system, using the schema registry is non-negotiable. Now, there are going to be people writing consumers at some point that maybe you haven't talked through everything with. Again, in a non-trivial system at organizational scale. And they're going to need a standard way of learning about that schema and some kind of automated way of negotiating the changes around that schema. No matter how good of a job you do defining things up front, the world out there changes. Your schemas are going to change too. This is another thing we'll talk about briefly in the last module. Confluent Cloud has features on top of the schema registry that help you govern data and publish catalogs and manage change at scale in a way in a large organization that you're always going to have to. So I think a non-negotiable part of your non-trivial Kafka-based system.